Hello, my name is Noha, and this is Physics 2, Lab 2, Lines of Charge. For this video lab report, we will compute a computational model of two tapes that have equally distributed charges and compare its result to Lab 1. For the purpose, we want to see if the result varies between distributed charges and single point charges. For fundamental principles, we have Newton's second law, which is F equals ma, Coulomb's law, which is the electrical force equals 1 over 4 times pi times epsilon naught times q1 times q2 over r squared times the point charge, and gravitational force, which is Fg equals mg. So as a result of this model, the line of charge model was found to have a greater charge value than the point charge model, and the electric force calculated with the new charge we found offset the gravitational force. For initial conditions, we have tape B to be our system, tape A and Earth for our surroundings. Mass of the tape was 0.00022 kilograms, length of the tape was 0.22 meters, distance between the two tapes was 0.18 meters. So for this computational model, we assume that each U-tape has the same net charge, and the charge of each tape are uniformly distributed along its surface. So these are the two most important functions that I used in the computational model. First, the E-field function, which just simply follows Coulomb's law and is defined using global variables specified in the initial conditions. And the second one is the line charge function, which kind of depends on the input n, and which represents the number of point charges in the tape. So for the actual use of functions, top tape and the bottom tape were defined using the line charge function and was arbitrarily set to 100, and it's just merely an assumption. The position of tape was adjusted to the origin while keeping the distance relationship with tape A the same. For the result, the charge on one piece of tape using the line charge model was 1.59762 times greater than the charge on one piece of tape using the point charge model, and using the new charge we found, the electric force and the gravitational force fully canceled each other out. So as in summary, the point charge model had a charge of 8.814 times 10 to the negative 9 coulombs, while the line of charge model had a charge of 14.083 times 10 to the negative 9 coulombs. For similarities, both models had their net force equal to 0. However, for differences, the charge calculated using the line charge model is approximately 159.78% of the charge calculated using the point charge model. For potential sources of errors, similar to Lab 1, a piece of tape was treated as a 2D object. However, in reality, everything's in 3D, so it may introduce some errors. Forces like tension and drag were not taken into account, which could have reduced the precision of the result. And the number of point charges in the one tape was manually set to 100, which could be significantly lower than the actual number. So I got point charge to be 8.81498 times 10 to the negative 9 coulombs, and line of charge to be 14.083 times 10 to the negative 9 coulombs. And the question asks, if you were to model the computational model as a single point charge rather than a line of charge, would that yield the same result as the experimental model? And the answer is yes, and that is likely due to the assumption we made before, saying that the two tapes have equal charges. Discussion 2. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? The estimates differ due to the varying assumptions made about charges, and the line charge model is closer to the real value since objects cannot be considered point charges unless they're very far from the observation point. So in conclusion, the tape's charge was inconsistent between the line charge model and the point charge model. The line charge model yielded a greater charge value for one piece of tape, and the line charge model is still not fully accurate due to potential sources of errors. That's it for today. Thank you for listening.